Okay, welcome to AP Physics today. So now that we've figured out that you can't push nothing, we're going to have to see how that works with the math. Okay, so let's just take a little look at this. If I have a ball that weighs 10 newtons, what's the tension on that rope? 10, right? Okay, so now let's say that I have a pulley. Okay, so whenever we talk about pulleys, they're massless and frictionless, which means all they do is change direction, okay, of the force. So here's the light string, okay, and let's say I have 2 kilograms here, and let's say I have 3 kilograms here. Okay, so the first question that you might ask yourself is this. If I had tension from this side, okay, what would it be? What would the tension in the rope be if the red line, squiggly line was solid? It would be 30, right? And the tension over here would be 20, right? If this thing could move. Or if I locked up that pulley, I would have 2 different tensions. Do you agree? On the left it would be 30, on the right it would be 20. But that isn't the case. Okay, so my question to you then is the tension in this rope, okay, I'll tell you right now, since this pulley is massless and frictionless, the tension is exactly the same on both sides, okay? But the question is, which way is this system going to move? Is it going to move to the right or to the left? To the left, right? It's going to move this way, and how do you know that? Well, if you think of this as a tug-of-war situation, the Earth, okay, or the force of gravity on this is 30 here. The force of gravity on this is 20, right? So you can say that the 3 kilogram mass wins the tug-of-war because it has this bigger interaction with the Earth, just like the friction thing, except for it's not friction anymore. Okay, so here's the big question to you. Is tension, I'm going to call this T1 and T2. And then I'm going to think right here is going to be an equal sign. And I'm going to say that for my math, I can assume, because you can't pull nothing, that T1 equals T2. Okay? But here's the question. Is the tension going to be greater than, equal to, or less than 30? The answer less than is correct. So if you think of, you've done this 1,000 times. You have a football, right? And you throw the football, and let's say it's coming really, really fast. Do you just stick your hand up in the air and catch it? No. What you do is you go with the ball, right? So you move. You start touching at this point, but then you move your hand that way, right? Because it hurts less. Or a baseball might have been a better idea, right? Do you know what I'm talking about? Going with the ball when you catch something. Okay, so everyone knows what go with the ball means. You move your hands in the direction of the ball, until you bring it to a stop. So, thinking about how that affects this. Because if that rope was still, it'd be 30 newtons. But what's happening to this mass? That mass goes with the system. Just like your hand went with the ball here, that mass goes with the system. So it's going to put less force on the rope than its actual weight because it's accelerating downwards. You could think about it a couple different ways. Like if you jumped into an elevator that was accelerating down at 9.8 meters per second squared, the elevator would be, and you would be going with gravity, right? So you wouldn't be able to measure your weight because the elevator is moving away from you as fast as you're moving towards the center of the Earth. Does that make sense? So in that same way, there's part of the weight that you can't measure here because the mass is going with the system. So this tension then has to be less than 30. Well, let's look over at this side. Okay, so is tension going to be greater than, equal to, or less than 20? Okay, so again, if we just lock this, if we lock this pulley up here, it'd be 20 exactly, right? But the thing is, there's going to be an acceleration in this direction, so it's going to be greater than 20. Because if the tension was just 20, the thing wouldn't be accelerating. But if it's more than 20, then it will finally accelerate. Okay, so then you might be asking, well, how in the world do you do the problem? Right? Well, the easiest or the hardest part of these problems is the talk through about who wins a tug of war and why. Well, maybe even harder than that is the whole idea that you can't push nothing. So T1 is equal to T2 no matter what. So I'm just going to put in the forces here right away. Oops, I did that backwards, didn't I? I had 20 newtons here before. Okay, so now if we think of the summation of forces, this is kind of the main formula that I use. You can do this a bunch of different ways. I'm going to show this way, but then there's also other ways to do it. I show it this way because in the end it becomes easier, I think, when the problems become more difficult. And more importantly, it exemplifies Newton's third law and the fact that you can't push nothing. So T1, so I'm going to label this T1, I'm going to label this T2. And then I'm going to put in all the forces. So I know you got to start out with 30 newtons because that has to be factored in there somewhere. Because that's what the weight would be if there was no acceleration. Then you go minus mass times acceleration of the system. Okay? So, don't forget, force equals mass times acceleration of the system. So if I have MA, that is a force. You couldn't subtract one force from another force anyway. So mathematically that, it has to be a force. And then T2 then becomes 20 newtons plus mass, and I better put mass 2 times acceleration of the system. And I'll say that this one was mass 1. Okay, so now you can see all you have is one unknown, which is the acceleration of the system. Right? So you just go ahead and you start solving. Subtract this from both sides, so it's 10 newtons minus, what do we have? 3AS equals 2AS. Any questions about where those numbers come from? Okay, so then 10 newtons equals 5AS. Acceleration of the system then becomes 2 meters per second squared. Okay, and so now to solve for tension, you just remember this side is tension, they're equal to each other. So then in reality I have two formulas that I could use to solve for tension. Either one, it doesn't matter. So let's just use T1 then. So T1 equals 30 newtons minus mass times acceleration of mass 1 times acceleration of the system. So 30 minus, what is mass 1 is 3 times 2, 6. So T1 is 24 newtons. Now, was that greater than 20, less than 30? Okay, so that's the right answer then. At least it's a logical answer. Okay, here's another type of problem because the tug of war is a little less straightforward, but it's still a tug of war. So the first thing you have to do with all these problems is figure out who's going to win the tug of war. Later on we'll put in friction and things like that, but you don't ever think about friction until you figure out which way it's going to go because friction only opposes motion or potential motion. So we're going to start out with no friction. So the pull on the rope in this way is 21 newtons. Okay. The pull on the rope in this way is what? Sine of 30 times 40, right? Because if we draw our little force of gravity triangle, this is 40 newtons. If we draw our triangle the right way, theta is equal to theta. So the sine of 30 times 40. Any questions about that? Okay, so we know that now that it's going to be 20 newtons, right? So which way is this thing going to move? Okay, it's going to move this way. And that's what you have to do first of all in order to figure out how to set up your pluses and minuses for the rest of the problems, or for the rest of the problem. Okay, so let's call this T1, we'll call this T2, and if you start to define T1, well, first of all, without a doubt, we have to know absolutely that T1 equals T2. Now, if you think of the forces, T1 force it doesn't have the weight anymore, it's the 20 newtons, right? That's the part of gravity that's directed down the ramp. Now the question is it going to be plus or minus mass times acceleration of the system? Okay, so did we not agree that this thing was going to be pulling up the ramp? Which means it has to pull harder than the force down the ramp, which is 20 newtons. So is it plus or minus? It's plus. So it's plus, we'll call this M1, we'll call this M2. Okay, so plus M1 times acceleration of the system. Are there any other forces in this one? No. Okay. So we're going to say that equals T2. Okay, so we know that T2 is going to have 21 newtons pulling on the rope, right? Or we have to factor that in somewhere. Is it going to be 21? More or less? It's going to be less, right? Because this thing's going to be going with, just like you're catching that ball, it's going with the system. So it's going to have to be, how do we signify that mathematically? Minus M2 times acceleration of the system. Okay, are there any questions about how we set this up? Because really, this is, all the physics is done now. Okay, so now I said it's all math from here, the physics is done. So we just have to solve the problem, right? So 20 newtons plus, M1 is 4 times acceleration of the system equals 21 newtons minus M2 is 2.1 times acceleration of the system. Okay, so we add all that stuff together and we get 1 newton. Okay, so I subtracted that from both sides. Equals 6.1 accelerations of the system. Okay, you guys check my math. So the acceleration of the system then is 1 divided by 6.1, which equals 0.164 meters per second squared. Is that all the decimals that were in that number?
No, you kept going.
Well, what are the rest? That's acceptable then. Okay, but that's not the tension. That's the acceleration of the system. So now we have to plug that in either there or there. So I'll say T2, which is equal to T1, equals T2 again, which equals 21 minus M2 times acceleration of the system. In this case, 21 minus 2.1 times 0.164. And our tension then is 20.656 newtons, and that's your tension. So hopefully that helps you understand Newton's third law and helps you get a good grade on your assignment for tomorrow. Have a good day.